Alright, hello everyone. This is going to be just a short little walkthrough of my newest project, which is I designed a web application for signing in users, hashing the passwords, storing them in a PostgreSQL database, and then the main attraction is playing the snake game, which I'm sure a lot of you guys have played. And so this is just going to be a quick little walkthrough of, just the basic gist of it. Alright, I made myself itty bitty. So we can look at the GitHub, which I will link my GitHub below. I've got 2 other projects and a couple others that I'm planning on making very soon. But anyway, so we got the key technologies for this application. Pretty much just Node.js for the runtime, ExpressJS for the main framework, and handling all the different paths, and also I used, which I haven't actually used this before this project, was embedded JavaScript templates, which is very cool. It basically is a templating engine which allows you to basically just insert JavaScript without really having to do anything extra. I'll show it in a second, but it's very cool. I'm a big EJS fan now. PostgreSQL is the database that I use to store all the information, as you can see here. And Passport.js and bcrypt.js was used for all the authentication, and specifically bcrypt for the password hashing and salting, so that obviously people couldn't decrypt the password. So we've got the main app.js file. If we go into that quickly, yeah, I forgot to mention the PG library. I use that to connect to the Postgres database and transfer or access all the information into the actual JavaScript and runtime environment. So right here, the pool localhost, which is just my IP of this machine, my private IP address. My name is what I used for the actual user on the database. Game_users is the name of the database, and I just put password as password for my user, which not secure, but I'm not actually deploying this yet, so it doesn't really have to be secure. It's just for demonstration. Launch app.js. I'll make it a little less. There we go. Okay, I'll size this down. Okay, and port 3000 is the port that I am using, so I've got it running using Node, and now we can access the actual application while it's running by doing http localhost, which I could also type in my actual IP address and it would still access in the exact same way, but I'm not going to do that. So here is the actual website. So right now we are just in the root path. So where can we see that? Is index for the EJS file, and then passing in user, which is request.user, which I'll explain in a second. And so we've got index in the views folder, index.ejs. So this is EJS, which is basically just HTML, which you can embed data from the JavaScript environment, and that it is able to be accessed and changed just basically automatically. So locals is what is used for EJS to pass in the data. So if we go back, when we do this res.render, index is the file, and then this is the locals. This is what we're passing in, which is user request.user. And so if we go back up using Passport, you can, when we go into the actual query, it runs an actual PostgreSQL query because it's connected to the database, which is select everything from users where username equals the username inputted, and then constant user equals row 0, which that basically is row 0, I'll show that in a second, is the row with the ID. So user equals the specific ID for the user that is accessing the website. So if the username is correct, then it checks the password from the row which matches the ID. So I'll show that just now. So this is logging into the database. As you can see, my user is just my name. And if we do L to view the actual databases, you can see I just have one database that I made right now, which is game.users. These are all just like part of the system. So I can connect to that database, game.users, game_users. And then if we view the database, we can see we've got the one table, which is called the users table. And so now we can use the query, select everything from users, and right now I just have 4 rows, which is 4 unique users. We see the unique ID, and that is basically what is going on when you call that query in the app.js. It's using the ID, and then that ID, it is able to access all of the other information in the database. And so it can check if, say you try to log in using Danny, but the D is underscored, then it has access to the ID from the query. And it can be like, oh, well, that doesn't match up. I don't have any Danny's with all underscores, so there's no username that matches with that. And then if it matches with Danny, then it checks for the password. So let's go back to that. And this, yeah, I already showed that, but that specifies like the views directory is where all these EJS files are available, depending on what path you visit. But so yeah, like I showed for this, accesses the database with this query. It has all the info to access the database up here. It would not be able to otherwise. And so it runs this query, select everything from users where username, instead of like the query that I showed before, I just did select all from users. It would be the specific row. So where username, say, equals Danny, and then pass that in, and then assign user as the ID for Danny. And then the rest of it is just able to be accessed from that specific unique ID. And then, so let's actually log in. I'll quickly log into Danny. So Danny, this is not actually Danny. Oh wait, I typed that in wrong. It's not going to recognize. It searches the database, does not find any username, Danny, but if I type in Danny, if I actually mistype the password, it still does the same thing, or because one of the main rules of website security, you don't want to let the user know kind of what's going on the back end. So if I said incorrect username when they had the incorrect username, but if they had the correct username, so if they had Danny, but then they mistyped the password, and I let them know, hey, you've got the right username, but you have the wrong password. Well, then if someone is trying to access sensitive info for Danny, say we had sensitive info, then they could just try passwords on Danny because they know Danny exists. They just need to find the password. So I have it set up, incorrect username or password, as a little preemptive security. This is not a secure website right now, I'll tell you that. That would be bad. There we go, we got it. So then we are in the home directory, or the home path. Like I said, everything on the internet is just computers, and you're accessing them, accessing files, accessing folders and directories, interchangeable. So we're in the home folder, and let's go back. Which file was that? Home.ejs, that makes sense. So where can we find that? So when we log in successfully and we go into the home directory, there it is. Okay, so we logged in, and since it was successful, we were redirected to the home directory. If it did not work out, it would send failure message true, like you can see down here. It actually logs. If it's an incorrect username or password, it shows it to me, but it won't show it to the user on the front end for security purposes. But then if it is successful, redirects to the home path or home directory. So then when we use the GET request to actually view the home file in the path, then it's going to render home.ejs in the views directory, and then the stuff that is passed to the locals object, which is used in EJS to access whatever data you pass. We're passing in user, which is the request.user, which, like I showed before, that is what we get from a successful login. It makes this user object which holds all the information in that specific row for that specific ID from that specific username and that specific password. So then if we go to home, we can see this is how you access it. So locals.user.username, which when we were looking in that database, users, and I'll just show the actual query that you can use for like a specific user, or we could just do from users where, let's say, ID is greater than 2. And so it's only showing Rufus and Ben because what were the other two? Danny and something. They had IDs 1 and 2, so now we're only showing IDs greater than that, 3 and 4. But as you can see, it correlates ID, username, password, high score. All that data is accessed and then passed through to EJS through locals object, user, which is the table, username, which is the column in that specific row. So like we can see, home.ejs, so users homepage, and then if we go to there, like you can see, the title, Danny's homepage. So that's how you access that. And then same with account. All of that data is passed in, username, user ID. If we go back to account, you can see the same thing. Shows the same like Danny's account. Username, Danny. ID. ID is 2. High score, he hasn't played yet, so he actually doesn't have a high score yet. And then So we've got the actual snake game here, which is pretty self-explanatory, except what do I want to show at the very end to actually log stuff in the database? We have this function change direction, and so while the game is not over, that's what this means. Explanation. I need an explanation. Exclamation game over, so not game over. And where do we find game over? Let's see. Game over. Game over. There it is. Right? Yes. Game over, game over, game over. There we go. So, like, the game over conditions. So, if this would be like the snake goes out of bounds, so the x-axis for the snake is less than 0, it starts from like 0, 0 and goes down. So basically, like, if it goes over there, or over there, out of bounds, or over there, and then also, where is it? Snake body length. This is if it hits itself. So, like, if the x-axis of one of the pixels in the y-axis of one of the pixels is the same as the x and y axis of another pixel, that means that it ran into itself. So both of those would mean game over. And then so if we have game over, not game over yet, this is just WASD keys for directions. But if game is over, so else game is not, or what am I saying? If not game over, and then else, so if game is over, I bound it to the R key. So if snake body length is greater than the high score, because they're synchronous, the length of the snake body is your high score, then we make a new value and submit it to the database. So let's go back there. Let's play the game a little bit. Bam, 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 bam. What am I? Holy crap. That was like, that would be impressive if I was trying to do that. So let's just go to 2. Previous high score was nothing, or 0. So it says new high score, R to reset, and then that sends it to the database. And so now we can go back, view the database. Wait, what? Oh. Game users. Select everything from users. Whoa. Wait a second. What? Oh, did it do that weird thing? I think that's what it did. There we go. So as you can see, Danny has a new high score because all of the JavaScript and the PostgreSQL database and the EJS, basically HTML, it's all connected, which is very cool. It was very fun to make. Shout out to the Odin project. This is how I kind of learned, like, basically most of this. I'll go into greater detail in other videos where I'm going to be doing more development on it, more security aspects, changing up. Obviously, it does not look the greatest. It looks fine, but not, production worthy. So stay tuned for that. Hopefully this wasn't too rambly or too long, and that I explained everything okay. I didn't get into everything I wanted to talk about because there's so much cool stuff. But I don't want this to be a super long video. But if you do have anything that either I didn't explain or something, you can just type it in the comments. But that is basically it.